Imagine you are driving at night, and a grain of sand hits your windshield. You barely notice it. Now change one thing. That grain of sand is not in the air. It is in orbit. And it is coming at you at about 28,000 kilometers per hour. At that speed, even a paint fleck can punch like a bullet. A small bolt can tear through metal. And a collision is not an accident anymore. It is a detonation. Above our heads, there is a silent storm we cannot see with our eyes. We call it space debris, but that phrase sounds harmless, almost tidy. In reality, it is a moving minefield. Pieces of broken satellites. Dead rocket stages. Shattered fragments from past collisions. Even tiny chips shed from spacecraft over years. They do not fall gently. They keep circling. And every orbit they make is another chance to strike something we depend on. This matters because we now live through space, even if we never leave Earth. Weather forecasts, GPS, banking timestamps, global internet links, rescue signals, climate measurements, disaster monitoring, navigation at sea, communication during earthquakes. So many invisible threads of modern life run through satellites. When orbit becomes dangerous, the world below does not stay untouched. The sky is not just scenery anymore. It is infrastructure. And the numbers are not comforting. Space surveillance networks now track roughly 40,000 objects in orbit, and around 11,000 of those are active payloads. But tracking is only the surface layer, the part we can see clearly. The estimated population of dangerous debris larger than 1 centimeter is over 1.2 million, and the number of pieces between 1 millimeter and 1 centimeter is estimated around 140 million. In other words, orbit is not just crowded with big objects. It is filled with invisible shrapnel, too small to track individually, but large enough to ruin a mission. Avrupa Uze Ajansi. +1. To feel what that means, forget space for a moment and picture a highway. Now imagine every car is moving, but no one has brakes, no one can stop, and the lanes overlap in 3 dimensions. That is orbit. A place where speed is not a detail, it is the entire danger. Satellites and debris can travel near 17,000 miles per hour, and in head-on encounters the closing speed can be much higher. A collision at those velocities does not crack a panel. It fragments metal into clouds of new projectiles. One crash can create thousands of new risks. The Union of Concerned Scientists. +1. So how did we get here? Part of the answer is simple human habit. We build, we launch, we move on. For decades, rockets left behind stages. Satellites aged out and stayed where they died. Some broke apart because leftover fuel or batteries exploded long after their missions ended. And some were destroyed deliberately. Anti-satellite tests, done to prove a point on Earth, left scars in orbit that can last for generations. Each fragment is a new dice roll against everything flying nearby. The most frightening part is that the system can feed on itself. There is a chain reaction scenario scientists have warned about for years, often called the Kessler Syndrome. It is not science fiction. It is a simple, brutal logic. More objects means more close approaches. More close approaches means more collisions. More collisions means exponentially more fragments. Eventually, debris creates so many hazards that even if humans stopped launching tomorrow, the environment could keep getting worse because breakups are debris faster than the atmosphere can clean it up. ESA's own reporting is blunt about this. Not adding new debris is no longer enough. Active cleanup becomes necessary to avoid a runaway future. Avrupa Uze Ajansi. You can see the consequences already in the way space operations feel today. Space agencies and companies now spend real time and real fuel just to dodge what is up there. ESA notes that collision avoidance has become unavoidable in busy orbits, and that conjunction warnings keep rising as traffic increases. On average, ESA executes around a dozen collision avoidance maneuvers per year for its spacecraft. That is not a rare emergency. That is routine. Avrupa Uze Ajansi. +1. And if you want a human image, think about the International Space Station. It is one of the most protected places we have ever built, a home in the void. Yet it still has to move out of the way. NASA's Orbital Debris Quarterly News reports that the ISS has conducted a total of 41 collision avoidance maneuvers since 1999 to avoid tracked objects. 41 times, the station has had to shift its path because something dead and fast was coming too close. Orbital Debris Program Office. Now here is the uncomfortable truth. We cannot simply sweep orbit with a broom. Space is vast. Debris is fast. And even a small push in the wrong direction can make the situation worse. Cleaning up space is closer to removing needles from a hurricane than picking up trash from a beach. Still, solutions are taking shape, and they matter. Better tracking and data sharing so everyone sees the same danger. Smarter rules so satellites do not linger after they die. Designing spacecraft to passivate, to drain leftover energy, to avoid explosions after retirement. An active debris removal, missions built to capture or nudge the largest dead objects down into the atmosphere where they can burn up, because the big pieces are the ones that can spawn the worst fragment clouds. But none of this is only engineering. It is also a story about responsibility. Orbit is a shared space, a commons. No one owns the sky above the planet, yet everyone benefits from it. That makes the problem deeply human. It is the same pattern we have seen on oceans and in air and in climate. The temptation to use first and worry later. The belief that a little bit of mess is harmless. Until the mess starts moving at 28,000 kilometers per hour. So here is the final question to sit with. When future generations look up, what will they inherit from us? A clean pathway to exploration, discovery, and connection. Or a shell of chaos, a ring of fast-moving consequences that fences humanity in. Space debris is not just about rockets and satellites. It is about whether we can learn to treat the places we reach with the same care we wish we had shown at home.